history about flat Earth. Right. In about the 1500s, there was a man named Galileo, and he was under the authority. The main authority back in that day was the Catholic Church. Now, the Catholic Church asserted that the Earth was flat, and Galileo, he was a thinker. He asserted, he was an Enlightenment man. He asserted the fact. He said, no, I think the Earth is a sphere. And so he did a little math, and we think about that today. The Church accepted it. Now it's given fact that the Earth is a sphere. Every schoolboy in America is taught that we live on a spherical Earth. Columbus sailed across the ocean and didn't fall off. So, Matt, what is the shape of the Earth?
It's a sphere.
How do you know that?
That's what my mama told me.
Did you ever prove the Earth is a sphere?
My mama doesn't lie.
Neither does the Catholic Church.
Good one! I don't get it.
What?
I don't get it.
So that's the world we live in. We just accept truth blindly. So I use the same techniques that Galileo did, and I thought, no, the Earth can't be a sphere. It must be flat. So this was all my doctoral thesis, by the way. So I used a topic called Riemann geometry and general relativity, which some of you may have heard about. And using these topics, I came to the conclusion, well, the data points I had didn't fit properly if I assumed the Earth was a sphere. So it only worked in the flat model, which is what I concluded and proved in my doctoral thesis. Now, if you all know Dr. Gardner, he's read my work, and he agrees with me. He's a physics professor here. You're all welcome to look at it after. Anybody have any questions? Okay. Does anybody have the remote?
Oh, there you go.
Yeah, call him.
Now, I'd like to begin with a little picture. Now, we all know about general relativity. Einstein came up with it. It's been proven. In 1919, there was an expedition, and they basically proved that his tenets were right. That's a fact. Now, one of the tenets of general relativity is that light bends around gravitational fields. So, like, if you have the sun, for example, I can't draw. You have a light beam from like a distant star, like Alpha Centauri, for example. The light beam will bend around the sun, like that. That's been proven. That's true. Now, a lot of people argue that if the Earth was a sphere, then why do we see the boat traveling down a river? You see its mast disappear last. You don't see the whole thing the whole time. Now, this is very simple, and it's mostly regarded as like a pseudo argument because it's not really valid. So you have this boat. It's on water.
It's a good boat. It's a good boat.
Now this is an exaggeration. It's not really that close, but you see the mast, the light from the hull of the ship disappears. It does not reach the shore. You don't see it. It reaches the ground. But the light from the mast of the ship doesn't bend as far enough and hits the eye of the observer, which is why we see the ship disappearing from the bottom first. So I just wanted to get out of the way before any of you wanted to counter that. Now, This also helps prove why the Earth appears as a sphere from space. I'll show you this. This is Earth. It appears spherical, but why does it do that? Well, same tenets. Gravity bends around massive objects. So the Earth appears round, and in fact it is a sphere. But that's only because it appears as a sphere. In reality, it's all flat. Light is not really a good measuring tool. Just want to get that? Okay. Now, I want to show you another proof, okay? Gravity, everyone knows gravity falls down. Fact. You have a Earth-like object right here. It's all caught. People say that there's things under the Earth, like Antarctica or Australia. Doesn't work. If the Earth was a sphere, how come Australians don't fall off the Earth? It doesn't make sense to me. And Ben had a very interesting argument. Ben, would you like to explain us how gravity works?
Well, the force of gravity between two objects is based on the distance between them and the mass of the objects. The
mass of the objects.
But the distance, yes, the mass of the objects, and the distance between the center and mass of the two objects.
Right. So you're saying that even though the Earth is massive, things underneath it still fall towards it?
Yeah,
saying that? Yes?
I would say that's why gravity works.
What about, well, what's more massive than the universe? Shouldn't everything fall towards it?
No! No!
Certain parts of the universe are more massive.
Yeah, sure. I have a little documentary for everyone to see. It's really eye-opening. It changed my view.
Oh, God.
It's about 10 minutes long. It shouldn't be too long. Does this thing have sound?
Turn the volume.
Palm, turn it up. Turn it up.
You have to have another board.
Turn up on the left.
No, it works. It works on it.
Richard, help.
I think we got it.
This is my pre-calc teacher. He's insane.
Is there, wait, it's who?
Huh?
It's who?
It's my pre-calc. He's insane. No
Pre-calc teacher.
Doctorate, but only you're taking pre-calc.
It's in science, not math.
Very sorry about that.
Shrub, right click the sound. Yeah.
Shh.
Shrub, right click the sound button and palm.
Hold on.
It's Dr. Shrub to you.
Dr. Shrub, so.
It's Dr. Professor Shrub.
Doctor what?
Doctor of physics. I'm a physics professor.
Gotta hit keep changes. Gotta hit keep changes.
No, that's where my
Shrub, hurry, hit keep changes.
You have 4 seconds. 3, 2,
Disable the other one.
Barrel.
There we go.
You can enable the other one.
There's two parts. I don't
Antarctica.
have the original one.
Freezing. Barren. Seemingly endless. On December the 3rd, 1961, a 63-year-old woman by the name of Andrea Barnes set off single-handedly across this barrier of ice. On December the 18th, the weather turned against her. A week later, on Christmas Day, radio contact was lost. Miss Barnes was never seen again. This was to be the final leg in a journey that had started for her nearly half a century before. A journey ending in apparent failure. She had not succeeded in proving to the world that the Earth is flat.
Mass would indicate that there must be some depth, or wobble could very easily occur, and we know that there is none.
It's a commonly held misconception that the Earth is a spherical object that revolves around the Sun. But the fact is, of course, that the Earth is a circular dish surrounded by a barrier of ice that explorers like Andrea Barnes have been attempting to penetrate for centuries. In 1585, amid a storm of controversy and undercover